So I chose my favorite brain part to be the diencephalon. So what is it? So it's made up of the thalamus, the hypothalamus, and the pituitary gland. So as you can see right here. So this is the major regulatory system for most bodily functions. So this is because the thalamus actually acts as a quote-unquote relay station, so like a post office here or like customs at the airport. So everything has to go through it before it can get to its final destination. So all sensory and motor information that is going to the brain is sent through the thalamus to get routed to the correct part of the cerebral cortex for processing and interpretation further. So without the thalamus, the information might not go to the right place, or it might never actually get processed at all in the correct order. So it does actually serve as a first stage of processing to determine what is the most important information to kind of decide what should be prioritized. So it helps in regulating consciousness and states of arousal. So its role in regulating consciousness is thought to be because of its its ability to synchronize activity across the forebrain. So when you're thinking about sleep and waking, there's a lot of aspects of synchronous versus desynchronous activity. So that is why it seems to have a big impact on attention and consciousness, and it plays a role in learning and memory because of its connections to the limbic system. And so there's then the hypothalamus, so it's the body's coordination center. So it maintains homeostasis, so directly by influencing autonomic nervous system. So think controlling CO2 levels in the blood and just kind of monitoring, and then indirectly by sending signals with hormones and working with the pituitary gland to influence other systems. So this is how it works with a lot of things. This is why the hypothalamus is so connected. It works a lot with the pituitary gland to do this. So it's the main link between the nervous and endocrine systems because the hypothalamus is directly connected to the thalamus, which is a major central nervous system element, and then the pituitary gland, which is a major endocrine system thing. So that's why it's a major link between those two. So the hypothalamus, because of its unique position here, it does regulate a lot. So the biggest things it regulates are hunger, thirst, sexual behavior, and aggression. So the hypothalamus actually produces two of its own hormones, and then two of its own major hormones, and then it has a few others, but it then just sends signals to the pituitary gland to then release something else that will then do what it needs to do. So that's where the body temperature, blood pressure, and mood, and then sleep come into play. So it doesn't directly impact those things. That's a more indirect effect. But the hunger, thirst, sexual behavior, and aggression, so because of the two hormones that the hypothalamus produces, the major ones, those are mostly thirst, so vasopressin or antidiuretic hormone, which signals the body to take in more water, and then sexual behavior with the oxytocin, because that's the major hormone that is used for that. So next up is the pituitary gland. So it's part of the endocrine system, and it makes and releases hormones. That's pretty much all it does. So it does this to control functioning of other endocrine glands. So it's divided into the anterior pituitary, which is where hormones that are made in the pituitary are made and stored, and it's vascularly connected to the hypothalamus. So it's not as direct of a connection. It just receives signals. That portion receives signals from the hypothalamus. The posterior pituitary, it actually stores the hypothalamic hormones of vasopressin and oxytocin. So it is a more direct connection. But the pituitary gland kind of works like a thermostat. So it works with the hypothalamus to regulate body functions, and we actually call this the hypothalamus pituitary complex. So because they're so interconnected, it's got its own thing. So what would happen without each structure? So damage or removal of any of the structures would be almost detrimental to functioning biologically and behaviorally. So damage to the thalamus would obviously dysregulation of consciousness, and it can also insomnia, unconsciousness, and even in severe cases coma, because if your brain is not synchronizing activity correctly, you won't be able to maintain a consistent state of consciousness. Damage to the hypothalamus can cause issues with water retention or dehydration because of that vasopressin or antidiuretic hormone being messed up and how it's being released, higher low blood pressure, and issues with feelings of satiety because it works with managing blood pressure, also manages hunger. Pituitary damage is often signaled by hormone problems, so it can really present in a lot of different ways because of the vast ways the pituitary can affect you. So physically, with unregulated growth, or emotionally with depression or anxiety. So in conclusion, the diencephalon seems to do a lot of the behind-the-scenes work to keep us functioning, but although it seems that it's mostly autonomic behaviors rather than outward behavior, without any of these substructures, there'd be very significant deficits in outwardly perceived behavior, like emotional regulation, regulation of feeding behaviors, sleep, and sexual activity. So really, without the diencephalon, it would be very difficult to continue to be a quote unquote functioning person. So that's why I chose it as my favorite brain part. So I hope you enjoyed this presentation, and then these are just some of my references, but yeah, that's it. Thank you.